Um, we are going to see now this example that you see on your screen. It's a rotational system. We would like to do the bond graph model as well as the block diagram. So let's follow the steps suggested for mechanical systems, and then we'll obtain the block diagram. So let me disappear here now. And what we're going to do is we'll say, okay, the first step is for every distinct velocity we use a one junction. So I am going to put the one junction for the different omegas. This is omega 1. This obviously is omega 2. This right here, omega is equal to 0, is the wall, yeah? So, but I'm just going to write down that also as a reference point, that actually omega of the wall equals to 0. This would be omega 2, and this right here is omega 1. Okay, so that's the first step. Second step is attach those elements that see those velocities. So in here you have the element which is your torque input in here with value t, source of effort. You also have this I element with the value of the inertia over here, so it's this one and this. On this we have the other I element with value j sub 1. And in here I am going to put it as a source of flow with omega of the wall equals to 0. Yeah, for reference. The step number 3 would be to use 0 junctions to represent the 0 junctions to represent the velocity differences. Now obviously, and here we need the difference because the difference between this velocity and this one is what this 2c. So what I would do is we say, okay, omega 1 minus omega 2 produce this omega 1 minus omega 2, and these two elements see that difference. So in here we write it the C element, and then we write this other one, the R element with value v sub 2, and this with value 1 over k sub 2. We do the same thing on the other side. This is why I wanted to have that reference, the wall, because it makes it easier. This is omega 2 minus omega of the wall, and in between these two we also have the C and the R element. This is my bond graph model. Okay, so because I am if I were to do a simulation, I just put this into the CAMG. CAMG will assign all the causal marks and everything would be fine. But because I want to do the block diagram, I need to do that myself. Okay, so in here, the first thing we do is we assign let me just change colors here to make it more interesting. This is the causal mark. We put the I in integral form, and that makes this one like this. We go to the I and put it in integral form. The flowing to this makes the other two like this. And now you see what happens. You have two flows in here. This one needs an effort like this because 0 junction needs one effort. The flow is in here and then makes the other two like this. And you put the source of flow like this. That makes it like this, and this too. Force this to be like that, and this flowing here But force this two to be like this. Okay, next thing I need to do is to put numbers because I need to refer to it. I am gonna change colors once more and use blue numbers, yeah? So let's just do 1, and then you have 2, and then you have 3, then we have 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Alright, this is a good number of bonds in here. Because we have this complete like this, we are able to create our block diagram from here. I am going to first of all draw the structure of the block diagram. And so what I would do is we'll say, okay, in here we need to put the structure, which are the joints in here, and so the junctions is, I'm sorry. So in here I'm gonna say, okay, look, this is for the I1 is in here. I'm just gonna go, this bond is also like that. That corresponds to let's see. This one over here, see that one? This one over here is, hold on for a second. This we need to, do it for that too. So we have this other one too. And then we have for the I element up here, and then you have the other two in here like this, and then you have the I element over here, and you have the source of F over here. Do you see I am laying out the structure in here, just the bonds, these two here, then you have nothing here, but yeah, in here is the other two, and then for the C elements we need to put this one like this, the other two like this for the R element, this one like this, and one like this. See? So I have now the entire structure of my model, and I need to relate to the bond graph in here and then keep doing it. So I am going to do that in another color so that you can see the connections. Let's just do this in I'll just do it in red, and okay. So in here you have the source of flow in here like this. do you see how the flow F1 goes like this and E1 goes like this? This is SF1. Then you see you have a situation with these two bonds and the 0 here and the C. I think the best thing to do is to go and do the elements first. Do you see in this one you have that E sub 4 is the one, so this is E sub 4 and this is F sub 4. This E sub 4 is coming out of the C element. And so we do exactly what we have done today is integral form 1 over S, and then you have a if you want you could just write it like this. This is 1 over C sub 4, and then you have it for the R element. Do you see this is the value E sub 5, and then F sub 5. This whole thing is multiplied by R. This is F sub 5, and out comes this. So I could be doing this for each of the elements in here. Let's just do this 1 over C, and then you have the gain here, which is 1 over C sub 10. And then you have this in here, you have that this is E sub 10 and this is F sub 10, and I will continue here to the R element. On this other side is you have the flow, it goes in, this is F11 and then multiplies by, this is R, and then comes out this. And so I have done the R elements. I am going to go to the right hand side a little bit more in here to do the SC, which is, I find it will be easy to do. This one we're gonna do SE, what is the value? Number 18 in here, and this is E18 and this is F18, and I continue doing it. I will do the I element for this one on the right hand side. How do we do this? We integrate it by 1 over S, and then we have gain, that is 1 over I14, and that's the end of that. I could go over here to the E sub 7, and this is F sub 7, and this is, do you see how the effort goes in like this, gets integrated once, and then gets multiplied by 1 over I sub 7, and it comes out like this. So we have done the I element, we do this one, this one, this one. We did the 2 on the bottom, we did on the left. I think we did also on the left hand side, yes we did. So we are ready to put the connections, you see. So I'm ready to do this. So for this connection, let's say this one that is right here on the one that is hold on for a second. The one that is right here, all the flows and the efforts are the same, so we don't need to add anything other than write down in here that this is my coming into the junction, you have that this is E sub 2 and this is F sub 2. Yeah, and in here this all the efforts and the flow are the same, so this gets connected like this, see? Right there. But on this one right here, that's a whole different deal. On this one right here, all the efforts are the same. So we need to be able to say that. The one here is on number 3, do you see the effort is going up like that? So this is E sub 3 and this is F sub 3. So how do we connect this? All the efforts are the same, so this one needs to be, it's a zero junction, right? Do you see this one? This is E sub 6 and F sub 6 like this. But on the zero junction, the flows need to add. And how do they add? By the arrows control the way those add. So F sub 6 minus F2 is F3. So all we need to do here is we need to add these ones over here. How do we do it? Do you see the equation on this system, or the way it's written here, is saying that F sub 3 is equal to F sub 6 minus F sub 2. Yeah? And so the yeah, we're back in here. So we were over here, right? Right there is where we were. So F sub 3 is F sub 1, but in here you see is F sub 6 minus F sub 2. That means that right here, this is plus and this is minus. And done with that. Now we are going to go and do this one right here, this one. Do you see? In here, all the flows are the same. So let's connect one, all the flows are the same. See right here, this flow, and then this flow, all of them are the same. But the efforts will have to sum. So we draw the summation over here, and then you have to see how is the equation of the of this right in there. The equation, the way it's written here, says that E sub 3 is equal to E sub 4 plus E sub 5. So now we have to see in the block diagram that equation is also fulfilled there. But do you see how it is in the block diagram is, what is the output in the block diagram? It's E sub 3. Is that how my equation is written? E sub 3 is E4 plus E sub 5. So if that's the way it is. So E4 plus E sub 5, both positive, and we are done with that. And then we have the one over here, this one, right here. All the flows are the same. Pretty soon you get the hang of this. All the flows are the same. This one is F sub 8, which is going this way. and E sub 8 is this way. So the efforts will add, but how will they add? They are controlled by the equation, the way the summation is done. So in here we have, for this purpose, right here we have that E sub 8 minus E sub 6 is equal to E sub 7. And we have precisely E7 as the output. So E sub 8 is a plus, and then E sub 7, now E sub 6 is a minus, right here. And we are done with that. So we are going to go now to the zero junction here. See, we continue doing the same thing on every single one of them. All the efforts are the same, but the flows will add. So in this case, in that zero junction, you can see that E12 is going to the right and E8 is going to the left. So this is E sub 12, and then you have that F sub 12. Yeah. And so look at the equation again. Looking over here, you know that the equation is saying that F sub 9 is equal to F sub 12 minus F sub 8. And if that is the true, let's see which way is the output over here. See, this is F12 is like this, and F9 is like this. So I say F9 is F12 minus F sub 8. This is plus and minus, and we're done with that. And you see pretty soon the same procedure that we did on the left hand side, we have to do it on the right. But let's just make sure that, you know, for the one junction that we have in here, we have that E sub 9 is equal to E sub 10 plus E sub 11. And let's see if that can work over here. All the flows are the same. So in here I have to put all the flows the same right there. But the efforts will add like this. And so we have the equation. I said E9 is E10 plus E11. This was E11, and this is E sub 9 is going up. Yeah. So these two again, they are plus, both of those, plus and plus, and we only have one more left. You see how it gets little by little gets completed. The one on the right hand side, this one right here, is a one junction, this one. So in here we go and we say all the flows are the same. Sure, do this. All the efforts add. See, it's almost like there was a hole in there that needs to be filled. And this is E18. We are almost done in here. This is E14 is the one at the top in here. This is E14 and then F14. You see that F14 is coming out and this is going in like this. So in here we're gonna say that E14 is equal to E13 minus E12. So how is that? E14 is E13 minus E12, so this E13 is plus, minus E sub what did I say? It's 18, right? Not 13. I wrote it wrongly here. This is 18. 18 minus e sub 12 is 18, is 13. 13, it says, am I correct? This is, again, this is not 18, it's 13 here. And so this is E14 is E12 minus E13, and lo and behold, we have basically finished this block diagram in here. See if I can make it a little smaller in here so you can appreciate it completely. There you have the block diagram and the bond graph and the system all together. So this way you can see that basically there's a topological correspondence to the physical system when we originated this, and there is one also for the block diagram. So my recommendation, set the structure first, do the elements first, and then at the last do the connections, and then everything will be fine.